My talk is about library called HTML.jl, which basically allows you to render your stuff in WebGL. Let me introduce myself. I'm the only guy who is between you and lunch. So I'll try to be short and make it in 20 minutes. I work for UPC on now the Zigo, and what we are doing there, we are building UIs, or we may say operation systems for set-top boxes with JavaScript. Now, because of limited performance on these devices, we have a lot of problems trying to run at 60 FPS, and yeah, so we tried a lot of approaches, render with SVG, with Canvas, but yeah, we end up with WebGL. And it's a kind of embedded JavaScript. Not anyone does that. It's not that, you know, on demand. But why should you care? Because for mobile, it's also very actual. And yeah, performance optimization is a great phrase. I don't remember from which talk is it, but with performance optimization, you not only make your app faster, but you can do the things you was not able to do before. So yeah, the turtle can jump, and the rabbit is a bit faster, it can jump. Yeah. Yeah. So we found the DOM is slow. Now, many people nowadays found the DOM is slow. There is this React Canvas library. There are some another tries, and yeah, DOM is slow since it's quite complex model. And if you ever try to inspect one DOM element, like an object, and see what properties do it have, it's just a bunch of properties, hundreds of them, and definitely if you delete one, you have a ripple of events and so on. So yeah, once you touch the DOM node, you just create big chain reaction, like don't touch DOM elements. So let's see what is the difference between displaying image with DOM and with Canvas. The difference is huge. Basically, to operate DOM image, you need to create image tag, need to load file, need to append image tag, calculate styles, calculate position, and only then you display image. So with Canvas, it's much more easy. You just load file and draw image. Yeah, very, very straightforward. And yeah, DOM is slow. Even GPU DOM is slow because it changes only the last step. Basically, the different kind of display and image still creates a lot of events and so on. The next thing, bad thing about DOM, it's hardly predictable. So there is a screenshot of timeline. DOM, it's absolutely the same component. It's kind of carousel, rotating carousel with some perspective. And it's built with the engine, which allows to render in DOM and in Canvas. So the code is absolutely the same. Yeah, there is some difference in the inside of engine, but still it's small as well. But yeah, DOM is hardly predictable. As you see, there are a lot of repaints. Basically, we can't predict it. But there are a lot of rules, and you need to know them all, and it's hard to fail on this way. But for Canvas or WebGL, you decide when you render. So you need just to put your function, a render function on a request animation frame, and you are done. You are very, in a nice space, and yeah, it's much easier to predict and manage your performance, manage your FPS. HTML.jl do not use DOM, but only when you animate. So animations are a bottleneck. The rest is more or less fine, but when we are talking about 60 FPS stuff, we are talking about animations, about moving something. So when you are animating, you don't touch DOM using HTML.jl, but it still keeps inspectable when you do not animate. So DOM is not visible, but it's still inspectable. You can click on your WebGL content and inspect elements, and they are DOM. Yeah, also the nice thing is on the screen. What's that? That's a GPU and quite old. The good one is a lot of memory. You see a lot of chips, and all these chips, all this power to processors with two coolers, and it's the only aim for it is just to show some graphics. Basically, to composite layers. I think that nowadays so many people knows what GPU is, and so many people watch this video with Mythbusters. So no, I will not show it. Definitely, it's Moveton nowadays. So basically, the difference is that CPU draws like a very hardly working kid, like painting everything with a pencil. And to draw a rabbit or star, it needs a lot of time. And another approach to do it, just to use stamps. And if you have kids, you know that kids can do it very, very quickly with stamps or paint. So yeah, a kid with pencil is not that. Not that dangerous. Yeah, modern GPU can handle millions of textured surfaces. Millions of textured surfaces. Yeah, modern games using GPUs, they're really heavyweight in terms of graphics, in terms of effects. And let's see what modern GPU can do with OpenGL. OpenGL is basically the interface used to approach GPU calculation power and the way to communicate with GPU with its possibilities. So if you see there are thousands and thousands of polygons, squares, textured. Only the hand of this guy probably contains about 50,000 of polygons, 50,000 of textured and animated, and yeah, there are some effects, and still we have 60 FPS. And when I see that on some mobile device, which also have GPU, it's just simple slider, which is the only one textured surface junks. I'm really gone crazy. It's only one texture, and here we have thousands and thousands with crazy effects. And the same PC, you can get junk on just moving one image in HTML. So, yeah, the world is not perfect. Yeah, it junks because DOM is slow and complex model. GPU is not involved for full. Browser makes a lot of decisions, so I'll show in a demo. Browsers are too clever. Yeah, OpenGL is also available in web via WebGL, and now it's available on mobile devices. Let's see what we can do, what performance we can reach with WebGL. So what we see here is two bunnies jumping, and they're drawn with WebGL with help of GPU. So now we have two bunnies. Every bunny we can treat as animated div. Yeah, to make it useful for you and why we should care about bunnies. So two bunnies, 600 bunnies. Okay, let's have more. 4,000, 7,000, 10,000, 15,000 bunnies, and we going up, still 60 FPS. 25,000 bunnies, 40,000 bunnies. 50, we got a bit, still 60 FPS. Okay, so could you imagine 60,000 of animated divs? It's possible. It's a browser. You see, it's just Chrome. It's possible, really. Just use WebGL, just use your GPU, and you're done. You can draw as many bunnies as you need. So why don't we use WebGL? Why it's not widely used yet? So it's imperative, it's verbose, there is no ability to make layouts. And if we compare the code needed to display image in HTML and in WebGL, but it's not even pure WebGL, it's no raw WebGL, it's a 3JS library which makes it much more easier. I mean, rough WebGL would be 5 times more verbose. Could you imagine just displaying one image, something like that? And that's sad. But here comes HTML-GL, which is a game changer. The reason for that is it allows you to use WebGL in a very simple manner. You see, probably there is nothing to explain. Just wrap your stuff with HTML-GL tag. Of course, you need to animate HTML-GL tag instead of image after, but still, it's very easy comparing to this one. Much better. Yeah, so you just wrap your content with HTML-GL or use it as a jQuery plugin if you use jQuery. So how it works under the hood. So every time library, basically it's a custom element. So every time browser finds HTML-GL element, it rasterizes it to texture, then displays on a full screen WebGL surface. If element is changed, there are 2 cases. If we change layout or visual appearance of element, we re-render, so rasterize once more and display it. But if we change position, opacity, or rotation, not position, sorry, but transform, okay, of course. And yeah, so if we transform, if we change opacity, if we rotate, whatever, so we make it via WebGL, just rotating WebGL representation. It's very, very efficient in terms of performance, in terms of GPU utilization. The library relies on DOM mutation observer, so every scene element changes, you can see that. You re-render. On HTML to Canvas, which is a great library to get scene rasterized. And on Pixie.js as rendering engine, so it's the fastest one at the moment, the WebGL rendering scene. The most tricky one of these 3 is HTML to Canvas. It's really heavyweight. It's amazing library, which is very accurate in transforming something from HTML to Canvas to image, but really it's very heavyweight, and there are a lot of performance issues in terms of rasterization takes time. I have some tests in my blog. So basically, the rasterization of some average slider takes about 100 milliseconds. So it's quite a lot. I mean, so it's only bottleneck in all this scheme. So every time you change the content, you need some time it to be refreshed. Because of this HTML to Canvas workaround, it's much more better to have native, fast, and reliable rasterization API. If you are interested in, there is an article on my blog, the most recent one, about rasterization API. There is a grounding why we need it, how it could look like. But basically, it will break any bottlenecks in terms of making a fast WebGL from HTML, so on. Maybe it will help you to build your apps, not using a WebGL, but in other ways when you need to convert HTML to Canvas or to image, whatever. So let's go to examples, demos. Let's see. Okay, we have a. Okay, I'm try to decrease display. No, it's not possible. Okay. So what we see here is a DOM example. So I just want to show you that HTML-GL is very similar to HTML. Mostly there are no new conceptions. Now we see DOM, very simple DOM page. There are some elements. They're still wrapped with HTML-GL tag, so it's quite valid. It's valid. It's just custom tag. It's not registered. There is no behavior on it because library is just disabled. It's not included into a page. And what we do, we change with Velocity.js. There is library for animations. Many of you maybe used it. So we just animate it. If you C#, I mean not programming language, but if you just C#, you see that on the edge point, browser rasterizes. So it's animate, it's image a bit blurry, and then at edge point, browser makes assumption. Okay, we finished animation, we need to rasterize. But it's wrong assumption. Basically, you have two animations. Yeah, you have decision in your JavaScript to continue animation. It's just your top edge point. You need one more transition or whatever, but you don't need rasterization, because on a weak device, rasterization means junk. Okay, so in WebGL, you can control every rasterization step. So this is also a selling point. Yeah, so it's very simple demo. We are changing content via inner HTML. We are animating it via transform. Yeah, so let's move to HTML-GL analog. So what we see here is absolutely the same sheet. Almost no difference. The only thing that HTML-GL library is included, and when we animate, DOM node stays in place. So we basically animate WebGL representation, which as a facade, it has still DOM node. So we can still inspect it, and we can still change inner HTML. It's re-rendered in WebGL. So no new API, just use inner HTML or whatever, and you can do that. So next example is a bit more advanced. In DOM is the same, like it's some slider, sliding with mouse, and have alerts. So it's click it avatar. Yeah, we have some movie boxes. Click it avatar. Click it Breaking Bad. Click it ergo. So it's made simple with sorry, with on-click handler. It's a very rough way, but why do we need that? Is to show that all this stuff is still respected completely. All events are still respected completely in WebGL. So now we use it in WebGL, all slider, JavaScript. So definitely we use JavaScript to make it interactive. And all this JavaScript is still the same we would use in DOM. It still uses DOM events and so on. So, and it's still, so yeah, we see that when we inspect, DOM elements stay at place, but when we animate WebGL representation. Yes, so cool. Where to go next? It's easy to use. Yeah, so now we go to a more interesting thing, which we can't replicate in DOM, but we can do it in HTML-GL. Yeah, this is using of shaders. Yeah, we use some shaders. It's still interactive. It's still clickable. We still respect DOM events. I can say even more. We change in inspector. We change something. Hello HTML-GL. And it changes, basically. So it still stays HTML, but you can do, what we can do? For example, twist. It's still HTML, you can still change content. It's completely framework agnostic. This kind of thing, sorry, I clicked. Yeah, some filters like this, some filters like that. We can a bit pixelate, and then, I don't know. Blur is not interesting. Everybody can blur nowadays. So yeah, it still stays HTML. All you need, you can use filters. They're basically presets from Pixie.js. You can add your shaders if you know GLSL. Also, there is an idea to have filters and effects as plugins, and there are some plugins that could be really useful to PhoneGap developers. Yeah, so some PhoneGap goodie, which is very simple. So here we have very epish layout. Yes, so I will even make it a bit looks like a mobile phone. Yeah. So what do we have here? Poo, poo, poo. You can do it on every phone. So not every. Okay, Android 2 doesn't count. Yeah, but on iOS, on Android, you can do that. I never tried on Windows Mobile, so but I just don't have any. But yeah, you can do that. It's still HTML. It still respects all the stuff. We still have handlers for. So yeah, when we click, we still just console log. If we see source for this, we'll see it's very, very simple. I mean, in terms of let's see script. We see script. Okay, sorry. Yeah, it was the last one. Yeah, so it's just easily built with item add even listener. So it's just absolutely the same. Yeah, no new conceptions. FX as a plugin. Add your one. Add your one means there is a shader toy. You can reuse shaders if you know what shader toys means. It's just a collection, hundreds and thousands of shaders you can use in WebGL. Basically, it's kind of, you see it's interactive fire or whatever. There are a bunch of them. So everything you can imagine, there is a solution in a shader toy you can reuse in an HTML/GL. So it's framework agnostic, and we can expect React.jl. It's open source completely. You can use it. And this idea popped up when we organized a full-day workshop called Challenging Native. If you're interested in building applications which are able to challenge native platforms, you can go to our webpage and subscribe for workshop, and if we'll organize it near your place, you'll be notified. So there is a form. Feel free to do that. Yeah, so don't know, do we have time for questions? No. Okay.